Yeah, I only answer a question if it's both on the chat and the internet at the same time. If you're just in one, then you're getting ignored. Yeah, hey Brian, hey Thunder. Yeah, Thunder, send me your question so I can look at it, but I'll try. In the meantime, oh, there it is. 9b first. Ooh, are these complex variables? Yeah, sure, Brian. I guess a lot. When I streamed math on Tuesday, it was fairly busy, but if there's a break, I'll take a look. What the hell is this? Okay, thank you for sending me the answer key. Oh, it's one of those. Ugh. Oh wait. Oh. That's not so bad. Okay. So these are complex variables here. You said 9b first. I need to wrap my head around 9a. Because it looks like 9b relies on it. So I took a glance at the answer key. They basically say this is a geometric series, and you can apply the formula for the partial sum of the geometric series. I thought that they're doing some annoying factoring trick here, but they're actually not. Hey, SPQ. And so that's what you get if you do the formula for the partial sum. The equation is equivalent to z to the 8 equals 1. Why is that? Oh, because this is never, the denominator will never help you get to 0. This is only true if the numerator is 0. Okay. Okay, I'm on board, I think, with what they said for 9a. What do they want us to say for, what do they want us to do for 9b? Oh. Do the eighth roots of unity include the second and fourth roots of unity? Is that the idea? Because what's the second root of unity is 1 and -1? Or is there another one because we throw out 1? Yeah, I mean, let me just look at the answer because I am really not that strong on complex variables. I need to pay more attention to Penn Center's class. I missed out on a couple of the earlier classes, so maybe I need to go back, look back at the mission myself, or see if his VOD is still up. If we have z squared plus 1 equals 0, z squared equals -1. Forget everything. Okay. I don't, what? You can't just keep saying hence, answer key. with no commas or semicolons or periods. Oh my god, this sentence makes no sense to me. If we have z squared plus 1 equals 0, then z squared equals -1. And they're taking this and raising each side to the power of 4? I don't know what that... why that would imply that z squared plus 1 is a factor of z squared minus, or z to the 8 minus 1. Oh, like literally factoring the z to the 8th minus 1 as a difference between two squares. Yeah, that's a little too cheesy. That would probably work. It's probably this way is probably the more elegant way, but they're not. To me, at least, they're not explaining it in an elegant way. I don't get why you're. Yeah. But this, I guess, Brian, what I don't understand is this feels backwards. We're assuming the thing we want to be, or this feels backwards to me. Where we're starting with the thing we want to prove is true. It's like we're starting with the then and going backwards to the if to like, and with this line of logic. That's how I'm interpreting it. I feel like we would need to start with z to the 8th equals -1 and prove that z squared equals -1 and z to the 4th equals -1. That's what I'm confused about here. The answer key is wrong here? Oh, that would be great. Oh, okay. I wonder, like... I want to see what comes up with Google. I can't type. It's a problem. C to the 4th. Ah, I don't think Google cares about case. Why am I... Are factors of 1 plus z squared plus c cubed plus c. Am I really going to type out this entire thing? It's probably... Okay, fine. Okay, fine. Google wants me to type out the entire thing. So it's cool. I'm not mad. I don't see the exact question here. Oh well, okay. Yeah, let's just get to your next question then. Oh no. An ant walks forward 1 unit, then turns to the right by 2 pi over 9. It repeats this a further 3 times. Show that the distance of the ant from its initial position is sine of 4 pi over 9 divided by sine of pi over 9. We should be able to set up some right triangles here. We gotta draw this out though. Yeah, this one I feel like I can work it out. So yeah, I think this one might actually be kind of interesting, but it could also be annoying. Let's see. Law of cosines. Ooh. Okay. Oh, what? Complex numbers. Well, crap. It probably does lend itself well to complex numbers. I don't know. Crap. How do we use them though? Uh, okay, sure. Because I was gonna draw the shit out, but that was 2 pi over 9 radians. Anyway, probably like 15 degrees or something annoying. Huh. You're not sure if what you did is right. Comes to the function of moving forward one and then turning to the right by 2 pi over 9 by the function of x and the complex numbers by f of z equals e to the 2 pi I. Is there a minus in there, or is that just a weird fraction bar? Zoom and enhance. I'm going to take that as a weird fraction bar. Wait, no, it is a negative sign. Because you're turning to the right, which is clockwise, so you do need that minus. Okay. Well, yeah, I don't know how to do this, Fembox. With complex numbers, at least. Let's generally consume the ant starts from the origin. The final position of the ant after performing this 4 times is f to the power of 4 equals 0? It's probably easier with complex numbers. I was probably going to do it some convoluted way. I was going to draw it out and try to visually look at... I was imagining each time the ant moves and turns, you get a new right triangle, and you can try to geometry your way from one right triangle to the last one, basically. Yeah, Brian, that's like a good way of saying it. Like, I want to answer people's questions. I'm not here for, like, brain teasers. Necessarily. So I have no shame in just looking at the answer and trying to explain that rather than working it out for myself. So this is the way... the power of 4 here. You're confused on the stuff at the end? Okay. It's interesting. That's not or is this composition? This looks more like composition. Yeah, it's composition. The 2 minus 2 cosine 8 pi. It's the next step. Right here. And it's probably just a trig identity. I probably don't even need to understand the complex part yet. That from here to here. I bet you that's a yeah, that's a half angle identity. It's double angle, same thing. It is this identity right here, I think. The coefficients, it should be this identity. Hey, Phobos. You genius, big smart. Yeah, I don't know what happens with that. You do have to split off. Oh, no, you don't. No, yeah, it works out. Interesting. Okay. What are they right which identity they use? Yeah, true. I think at this point they just expect you to be able to work out that it's a trig identity. But it's not always obvious, so. School started today. Already third through this course's math book. Oh, right. You're just like way ahead of the curve there. Okay, so yeah, Thunder, I assume you got what you need to get out of this question then. Just for my own interest though, I want to see what the, I want to read through the entire solution and try to understand it. Fernie was just like hopping in, working on this question from Thunder. And so I was about to dive into just doing this like geometrically, or at least trying to. But apparently you're supposed to, they're intending you to use complex variables here. No worries, Thunder. Every identity is a trigger identity if you try to... Oh. Yeah. Oh, yeah. Yeah, I was trying to work out what trigger meant there. Yeah, I figured you meant trig. Oh yeah, sure. Feel free to keep it coming. Can the sine, cosine, sum functions be derived without geometry? You can apparently... I don't know if it counts as deriving them or just showing that it still works. Apparently, all these trig identities you can do with the complex definitions of sine and cosine. I don't know like formally how, if that counts as a proof or a derivation. Maybe it depends on how you've structured, like, I guess your algebra, but I'm just kind of throwing out fancy words right now, but all of these identities hold up with complex variables as far as I know. So you could bring everything to like e to the I whatever, and you'll find that these are still equal. I don't know if that's an actual derivation or not. And if outside of that complex variable way, I'm not aware of another non-geometric way of potentially proving these. You're saying part B. Okay. Oh, Taylor series. Yeah. I mean, Taylor series might have the same issue that, or I just don't know how to like, if you're accidentally doing something circular with either Taylor series or complex numbers, but it should hold up for Taylor series too. I just don't know how exactly the logic works for that. Well, I assume they want us to bring these cosines into their complex definitions then. I'm just gonna Google it to make sure I don't mess it up. I think I remember what it is, but cosine complex. It's like e to the x plus e to the negative ix over 2, I want to say, but I don't want to... But Wikipedia, just tell me the exact thing that I want, even though you have no way of knowing the exact thing that I want. Here we go. Hey, okay. I did remember it. All right, so let's see what happens when we just bring things into the complex definitions. Oh god, my headphone cord is caught. There we go. Cosine 2 pi over 5. 4 pi over 5? Yeah. So that cosine is going to be equal to e to the I 2 pi over 5 plus e to the minus I 2 pi over 5 over 2 plus e to the I 4 pi over 5. These are all Zach's cousins, by the way. 4 pi over 5 over 2. And then I guess you want to factor out a 1/2. And then what do we want to do with all these e's? We should hope, we're hoping they're equal to -1, I guess. I want Zach, we have Zach at home, e to the minus I pi. Oh, the cousin joke, thank you. Wait, I just want to make sure the YouTube stream is working. I feel like I didn't remember to check it. Okay, good, it is working. Do we want to factor, like, well, why wouldn't we use a half angle on this? Are we even supposed to do this complex thing? Or, like, this is double that angle. I feel like there's something fancy that we can do here with these e's, but I think I'm going down the wrong path. I would believe it. I'm just kind of assuming that we were supposed to start with this, but I feel like we could just apply a trig identity. I'm drawing a Zach family portrait. I think they are complex conjugates, Phobos. I would just, you know, plug into the complex definition of cosine there. What? Let me grab the answer to part A as well. How do we get to that first sentence? I'm already lost. Starting from part A. Oh, and hey, Mayron over on YouTube. I'm going to stream anytime. You don't understand any of it. I'm interested in math and problem solving generally for coding purposes. As a game dev for one day, any tips? That's a good question. Yeah, if you're interested in the math aspect of things, I haven't coded a game myself. This is where like we're gonna have like a translation issue almost, because like I don't know what you would need most, but if you want to be a game dev, like a knowledge of physics can be pretty helpful for simulating things accurately, like bullet physics, or even if like, you know, the path that your character should follow when you jump, like even like simple things like that, unless you're just using an engine that does it all for you. Another thing that can be helpful is getting comfortable with like sequences of numbers and just kind of like general problem solving. Actually, I've been doing some of this while just like if I have some downtime on the stream. It's called Project Euler. It's a website with coding problems that are based on math. So I was actually working on this one right here where and the problems range from like very easy to extremely difficult. So that like this is like one of the ones on the easy end of things. But like just like how do you find your way through this matrix while getting the minimal sum? So like I don't know exactly what kind of situation you find yourself in like as a game dev, but being able to solve problems like this, I imagine would come up pretty frequently. Yeah, it's like the thing that comes to mind, at least for me at first, Miran. Oh. Okay, so this is something where I should have looked at part A a bit harder then. Because I was wondering how part A was connected. I see what you're writing there, Brian, too. I'm just looking through this a bit harder first. So we know each of these individually equals 1, is that what we're saying? No, each one of those to the fifth equals 1. Okay. Z1 plus Z2, all of them added together equals 0. How does that work? If they're saying if you took all 5 of these roots, added them up, you get 0, I can see how the sines would cancel because sine is an odd function. The cosines would add together unless that double angle thing makes them offset. Is it just a fact that the roots add to 0 and I just don't know that? Hey, Tanae. Huh. Like, I'm wondering if there's just like a general formula says like the sum of the roots of unity or 0. Because I have no idea how else you know like this sentence in the beginning is true. And hey, CW, how do you approach a problem for solving for the volume of an n-dimensional sphere? That's a good question. I bet it's something that's been studied. I don't know off the top of my head, like, what I would do, though. Like, how would you define... I don't know how you define a sphere in higher dimensions. I'm sure there is one. I just don't exactly know, like, how that works. Do an n-dimensional integral? Or maybe what Scrimp says, yeah. Z to the n equals 1 have roots that form the corners of a perfect n-gon. So I guess, Brian, in your like string of logic there, you also had a similar looking equation where you add them up and set them equal to 0. Like, how do we know they're equal to 0? I assume it's something to do with that the corners are a perfect n-gon, but really? I should prove it. I don't know how. Look at someone else's proof. Use group theory. Order. Actually, okay, well, for the sake of answering Thunder's question, I don't want to go into trying to prove this. Like, Thunder, like, I should have asked you, like, where are you confused on this? Are you confused on the same thing as I am about this first, even like the first equation here? Or do you understand that and your confusion is somewhere else? Okay, so we do have the same confusion. It sounds like it's just a fact with complex numbers that the nth roots of unity add to 0. I wish I could, like, find something stating that on the internet, though. I'm not going for that argument. Oh, they're just rotations around the unit circle. Equally spaced. Is that it? Are we actually, well, aren't we changing the magnitude though? If they're... Shouldn't we have to multiply them, not add them? But then we're adding the roots of unity. So I'm seeing this like geometric sum argument here too, but I can't like work out what that means in my head, I guess. I think I can kind of see it. Is there a roots of unity visualizer? Visualization. Like, I just want to see the points. Oh, hey, GeoGebra. Move the slider. Okay, fifth roots of unity. I think, okay, yes. The point, I think, is that if we take all these fifth roots of unity, like pair up this root of unity right here with this one down here. The imaginary parts perfectly cancel, and you get a positive 0.62, I guess. And then if you look at the other pair over here on the left, the imaginary parts perfectly cancel again, and you get a minus 1.62. Oh, okay. Let me draw this out. That's the type of proof that not even proof, but like that's the type of like intuitive explanation that I wanted to see. Why the song kind of sucks. I'm gonna change the playlist. Oh, Spotify is taking forever. Come on. There we go. I mean, not Spotify. I would never use Spotify on stream. That'd be terrible. .31 plus 0.95i. .31 minus 0.95i. The point is that when we add these together, the imaginary parts are always going to cancel each other. And I want to quickly demonstrate with the fifth roots of unity here. Minus 0.81 plus 0.5. I wrote plus again, dude. Okay, so again, pair these two up, pair those two up. Well, we're really going to add all 5 of these together, but it'll be a bit more clear what's happening if we pair them up. Like I'm saying. So that's one root. Five I plus 1. And so the point is, that's a plus 0.59i, and that's a minus 0.59i. Same here with the plus and minus for the other pair here. So the imaginary parts perfectly cancel each other because of this like symmetry. The minus 0.8 ones, they just add to minus 1.62. The 0.3 ones add to plus 0.62. And the 1 is just a 1. And look at that. Minus 1.62 plus 1.62 is 0. So I think there's the fact that the roots of if you take all the roots of unity for a given n and add them together, you just always get 0 because of that cancellation. It's always going to have that kind of like symmetry, I think. It isn't the song, it's the trig. It very well might be. The vectors all like perfectly cancel each other. So the making a loop part, oh yeah, you know what? I think the making loop part, yeah, if you start from 0 and you like add the vectors together, you should get a loop that ends you back at 0. I think that's what you're asking. Okay. So that's the first line explained. So, you know, a bunch more lines to go. But was that your only question about this? Or was there, do you want to know about anything like, you got the rest? Okay, cool. And again, just for my own interest, I'm going to keep on looking at the rest of the solution. So yeah, the signs are all going to cancel. Hey, Cloud. And the cosines are going to combine, right? Subtract over the 1, and you just divide out the 2. Okay, that's... After the first line, it's not so bad. And what's up with this ant problem? So we compose this with itself 4 times. Oh wait, is this... It's not necessarily composition. What is this? Oh, that's magnitude 1. Okay. I see. It's not composition. This is where you end up after the first traveling distance 1 and turning to the right. Is it? What? What? Why isn't f of 0 equal to 1? You only turn to the right after you walk. Now I'm doubting this definition of f of z. I can see, like, intuitively how you're just adding 1 to z for moving forward. What's the definition of forward? Maybe that's why this looks like this. Because forward is wherever we stopped. Is whatever direction we ended at during the last walk. Oh my god, that's a good stretch. I think I kind of half understand this function. I can show it for a little bit here, Brian, but I can look at one at a time, so I'm going to flip back to this solution in a minute here. If you want to like have it copy to keep, then take a screenshot of it. Because, like, to me, f of or like the first time we walk forward 1 unit and then turn to the right, we should be at I. Well, what's our initial orientation, I guess? The orientation, I guess, doesn't matter. Because you're going to be the same distance away. Maybe that's why it's okay. Diagram where the ant walks along the positive side of the x-axis by 1 and then rotates up by 2 pi over 9. Well, if you're rotating up by 2 pi over 9, isn't that a left turn, not a right turn? It's probably still symmetric to get the right answer. But I think for turning to the right, okay, yeah. I assume they're starting them with e to the 2 pi I over 9, or minus that, because the original orientation doesn't matter. So maybe I'm more on board with this now. For modules of the geometric series formula. Oh, okay. Use GeoGebra? Yeah. It's the real answer. So this isn't necessarily... It's kind of like composition. It's almost more like recursive. I'm not good enough with I'm not good enough with using GeoGebra to be able to draw this out. The few times I've tried to use it, I've raged at it. But if someone else wants to try it, I'll look at it. Just a geometric series between some. So they applied the partial sum for a geometric series here. They apparently love using this technique. I wonder if it just comes up a lot with complex numbers. It seemed like they factor out an 8 to the minus, maybe to make the formula a bit clearer what's happening. Why is this squared? Oh, they're doing it to make the calculation easier, I guess. They're just arbitrarily getting the modulus of z squared for fun, just because they know it's going to work out, which seems a little cheesy. Hey, Mercury. This solution key seems like it's doing a lot of things. It's taking a lot of shortcuts because they already know what the answer is. I feel like this little part down here. It's not a solution that you would find, or I wouldn't think to do this modulus of z squared thing at least. So maybe it's a common thing with complex variables and I just don't know them enough. Whatever, I think I understand it. They start with this weird looking function because it's just it's repeatable. Whereas the orientation that I was thinking to use initially isn't repeatable in the same way. Okay, I guess that's good enough for me then. I might look at this project Euler problem then. Because at the end of my stream on Tuesday, Jed had a very good idea for how to solve it, and I want to see if I can implement it. Gave up on GeoGebra. That's been my experience trying to use GeoGebra as well. It's no shame. Oh, that'd probably be helpful. I just prefer to rage at things and not try to, and not actually learn them. Skillshare is a scam? Oh, I didn't hear that. I've seen like some YouTubers that I watch like do reads for Skillshare, like, you know, have like adds. I hadn't heard that part though. So Jed's idea here was basically look at they call the odd diagonals or something. Like we start from 131 and then we want to look just at 201 and just at 673 and get the shortest path to each of those is going to be starting from 131. That's a forced choice. So we're going to take the 201, add 131 to it, take the 673 and add 131 to it. But then we have a more interesting choice in this next diagonal. Well, not for the 96 at least, it's a more interesting choice. For 96, we're going to look left and we're going to look up. And whichever one is a smaller number, we're going to take that one and add it to this 96. And that's going to like represent our shortest path. The 630 is a forced choice because you can only come at it from above, and the 234 is a forced choice, you can only come at it from the left. So then going to this next diagonal, same like forced choice for 537 and 103. For the 803, you again look left and look up, choose the smaller. For 342, you look left, look up, choose the smaller. And you can do that working way through the diagonals, and I think compute this a lot more efficiently than my initial thing that I tried, which was doing every possible path recursively. So we have an 80 by 80 matrix loaded in to work through. I am kind of curious to run my function on a smaller matrix and see if it gets the right answer. What's the common BC math? Brian, I don't know why I spelled out your name, but how do we want to set up the sloop though? How do you count the diagonals in a matrix? Can you always avoid the largest number in the matrix? Maybe, yeah. I would think so. Maybe it's in some really crappy, like maybe if it's at the very end, like where the 37 or 956 is, I can maybe, and they're like all ones otherwise, maybe there's some extreme situation where you can't. I'm not sure, but can you make dead zones? I mean, at least for this algorithm that like Jed came up with, I don't know that there'd be a huge benefit to doing that. At least for an 80 by 80 matrix like the one that we're given. Maybe if you had a giant one, then it'd be worth doing. I think let's do a while loop. So like if we took I and j equal to 0 and 0, does that work in Python? These are two, and yeah, I think that's okay. So we could say like while I is less than matrix.shape, I think, or matrix.shape 0. To get, that'd be the number of rows. I don't know, we can just say it's always a square matrix and not care about j, I think. Oh, res. Thank you for the follow. Appreciate it. Um, oh shoot, you know what? That's not gonna work like I was thinking. It is the Dondo. Dondo. Hope you're doing well. Yo, yeah, this is just something that I've been doing while I'm waiting to see if there's a question from chat. We did have one before from Thunder with complex numbers. I know things are slow again. I'm just doing this like coding problem to fill in some time. Doing it seems like a good vibe while I work. Oh, well, thank you. Yeah, I'm hopefully gonna be on Daisy tomorrow. Brain still hurt after ant walk in the nonagon. Does it make a nonagon? I guess if you're doing... It depends on what 2 pi over 9 is. How do you convert that? You do... It's like 180 over 2 pi times the angle in radians. So 180 times 2 divided by 9. Yeah, no worries, Chris. Anyone's welcome to like be here. And I completely understand like if someone would not want to watch a math stream because not everyone has to like math, but I appreciate you hanging out for the vibes. It's gonna bother me. How do you convert angle in radians to degrees? I think I said it right. Just tell me the answer. Website. Degrees equals radians times 1/8. Oh, hey, I did remember it right. So yeah, 360 over 9. That's 69. 40? That can't be 40. Right? Not a gun. Not gun. Oh my god, right? Oh. We need it. Mananagan. Oh, hard locked. You have 100 customers waiting for a table and 30 people at tables. 20 people want sugar water. How long until Jen makes the restaurant fail? As someone who's been on the receiving end of like trying to serve those tables while the other person has a tray stand, it is hard to keep up. The tray stand is just too OP and played up. What was the angle again? 2 pi. I can't even slightly do mental math right now. Or times 180 over pi. Just make Wolfram Alpha do all the math for me. It is 40. I did it right. Okay. That seems way too big for 2 pi over 9. I thought it'd be something really small. That's why I put it into Wolfram Alpha. Yeah, that was a good run. Did someone knock on my door? I can't tell. Let me check that quickly. Sorry about this. Okay. It wasn't. Dude, is there anything worse than someone knocking on your door and having to like talk to a stranger? It was me, I brought you pizza. That would I would welcome. I'd be a little creeped out, but if you had pizza, I think that would make it all better. I mean, I will admit that sometimes if someone's knocked on my door, I just like try not to move or make any noise and hope they go away if I'm really not feeling it that day. Pizza beats creepy? It does. I hide if I see them in the window. They need something, you send the kids. That's the technique right there. It's the real advantage to being a dad. You hate, yeah, same. Like the self-checkout at grocery stores, I do feel bad that means that they hire less cashiers, but it's also like, oh man, I can do this chore not to talk to people. It's fantastic. Someone knocking my door with a deal to my yard, but that's okay. Oh, okay. I'm pretty lucky where I'm a renter and the landlord just takes care of the yard work. If I did have to deal with that, I might be open to that too. Yard work kind of sucks. I've had to weed whack when I was a kid on like super hot summer days. That was not fun. Um, Don does not mow. If I could go my entire life without mowing the lawn, that would be great. Landlord does it for you. You're a jerk, and HOA are ruthless. Oh, you have to do your own yard work, and you don't even own it. That sucks. And the HOA should be going after your landlord, I feel like. I'm trying to think. The last place I rented, it was a condo which has an HOA. I didn't even know how to contact the HOA though. Like, they could only talk to my landlord. Unless they knocked on my door, I guess, but they never did. That sucks though. I've seen like stories of HOAs being like the absolute worst. It's some shit, yeah. Oh, and yeah, you can curse all you want as far as I care. Fuck, shit, pussy, all that good stuff. If you want to censor yourself, that's cool too, but don't feel like you have to do it on my behalf at least. Balls, there you go. Balls are always welcome in this chat. 120 degrees? Oh my god. It's terrible. I start, like, I'm in California, so it gets pretty hot, but not that hot. And 120 degrees, I think I would just die. I'm not a fan of the heat. I guess we don't really want to start with 0, 0. I guess we want to start with 1, 0? Huh. Okay, I think I see what's going to happen. Maybe. I'm trying to figure out how exactly we're going to track our indices as we try to do these diagonals. Arizona so miserable, do not recommend. Oh, that's right, Arizona. I visited. I want to live somewhere where it's cold. I feel like I would enjoy it a lot more. I'm in Northern California too, so it's not even like as hot as it could be, but it's still too hot for me. No, I mean, I don't mind chatting too. It's fun. If I can do both at the same time, that's great, but Sometimes I'll just like look away for a bit and then I'll go back to chatting or something, or I don't know. So we're gonna start. I guess we want like a temporary I and a temporary j. Temp I equals I. Temp j equals j. So the first thing we're gonna do, I want to start by traveling. In looking at CIS, I'm gonna start by like on the left side or the bottom of the diagonals, depending on how far along I am, and then go up and to the right until I reach the top or the right. So like on this first pass, we're gonna start with a 201, and we have to add the one above it. Myron says it's 42 Celsius here? Isn't that like, that's something crazy high, isn't it? $107.6? Oh geez, yeah, that's not fun. $3.14 equals pi, hell yeah. Ask me like, I feel like the most like memed on thing in like when I see like my chat and other like math chats where it's like people just like say like pi equals 3 or pi equals 4 or like Thunder 22 or 7 equals pi. Just doing like the worst estimates that we can come up with. Sounds about right. Yeah, I mean 22/7 is at least not a terrible approximation, but like pi equals 4 is like the funniest one to me. Pi equals 4 on a good day. Cheap viewers. Bluegrass karting? I want to go go-karting. Those bots are so annoying. At least they're making their links more appealing, though. What's up with Bluegrass Thunder? Matrix, temp I, temp j. I really should make a copy of this matrix, but that's fine. Does plus equal work in Python? I think it does. I hope it does. It'd be annoying if it doesn't. Work call? All right, see you in a bit, Rez. Oh wait, no. This is already if temp I is equal to matrix dot shape 0 minus 1. That means we're at the bottom, and now we're here. We started at the top, and now we're at the bottom, or the opposite of Drake. We're going to take matrix temp I, temp j. Yeah, okay, I think this is fine. Plus equal. This means we're at the bottom. Oh god, we need to make sure, see if we're in the corner though. We can't just check if we're at the bottom. Ugh. And temp j is equal to 0. Then we're in the corner. Bottom left corner. Plus equal, you want to go the... Well, No. We shouldn't do it like this. Should we? We should do, if it's not 0. Bottom row, not bottom left corner. Which means we can safely add to the left. Matrix temp I, temp j minus 1 is the left. Okay. In any other case, else, we're going to do this, but add from above. Which means we do I minus 1 rather than j minus 1. Left side, including bottom left corner. Okay. So that deals with the forced choice we have when we're on the left side or the bottom side. Now we want to do something, I'm sure. While temp I is less than... This is the part where we're going to start working our way up and to the right, up and to the right, up and to the right until we hit the right side or the top. Can you self-promote a bit? Yeah, sure. I just saw, I don't know if you're watching the stream, Valor, but if you happen to be in chat, feel free to speak up here too. Okay. Oh, and hey, Poonam, I saw you put something in YouTube chat, but I didn't quite catch it. And hey, Pranav, Torkad. Sing I'm bored to tears at home, and if anyone wants free coding lessons. Oh, nice. Well, I hope that someone takes you up on that, and it helps out with your boredom. If you want, feel free to put out the offer in my Discord, too. Oh, shoot, you know what? Are you streaming for that BCE math account? I just realized I should probably hit follow as well. No worries. Hey, Valor, or aka Cat Lord. Um, okay, yeah, I absolutely just hit follow on Brian BC Math. Um, so yeah, Cat Lord, I saw your message. I wouldn't want to make a, or I mean, I can reply to you in like the message too. I don't know if you have a preference, but like the code problems even here, there, everywhere. Yeah. Yeah, yeah. I'll reply in a DM. Poonam Tiwari asks, sir, can you please make video on integration formula? What type of integration problem are you curious about? Sorry, I'm just going to take a minute to reply to this, and then I'll get back to the. It is per project Euler rather than leak code, but similar idea. Okay. No worries, Catward. Code 64 minimum path sum. Oh, really? They have the exact same problem? Yeah. I'm not surprised. Leak code problems ever. Would you be happier if I was doing this in Rust at SPQ? Um, so temp I is the row that I'm going to look at. And so when do I want to stop with the rows? I want to stop with the rows when I'm just past 0. Or temp J. And we don't want to go off the right side. So matrix.shape1. This is a Project Euler question, Cat Lord, that I'm just going to fill in the time while I wait to see if someone in chat has a question. It's over on the left side of the screen. I'm working to implement an algorithm that Jed suggested when I was working on this on Tuesday. But trying to figure out the indices is a little bit annoying. Pen, hey! Exactly. I mean, there is a matrix. It's not really linear algebra, though, I guess. I don't know. I haven't seen you do much coding, but maybe it's the type of problem that you enjoy, too. Fine. I mean, we could get the eigenvectors of this. Well, actually, not of that 5 by 5 on screen. We're given an 80 by 80 matrix. You know, if it makes you happy, we could get the eigenvectors of that 80 by 80 matrix. Does NumPy do that for me? Like, oh, come on. NumPy has to get the eigenvectors, right? I just have to find the right function. NumPy eigenvectors. NumPy.linalge.eig. There we go. 80 by 80 breh. Yeah. Import numpy.linalge as ln. No, that's what? That's a terrible. Why would I do that? Why would I do that? No, just do numpy.linalge. numpy.linalge.eig matrix print. Getting the worst variable names possible. There you go. Wait, are those eigenvalues or eigenvectors? Eigenvalues and right eigenvectors. I don't know how to read the output, but we're getting both of them. Oh, these are the eigenvalues here. Why are they complex? Oh, because they can be complex. There you go. There's your dose of linear algebra. Sadly, I was born in 80. You have exposed your true identity. Oh shoot, I took away the problem, didn't I? Oh, Pen, we just had some complex variable problems. Can I get them to come back up? That Thunderfix asked. It's like we had this one. The solution was super funky. I need to go back and like either go through the material or like watch your VODs if they're still there of the earlier complex variables class. So I missed a couple. I wasn't able to figure out this one from scratch, but I was at least able to figure out like what the solution key was saying. So those roots of uni problems are so awesome. I need to learn the techniques more before I feel like I can like render judgments. Or right now, like things are coming out of the blue for me, and I find that annoying. But it's probably my own like inexperience. But yeah. Also, why does NumPy use j for the square root of -1? It's kind of disturbing. I think it's an engineering thing. Anyway. So we need to, before we go into this loop, we do want to increment temp I and temp j. Python doesn't do plus plus, does it? No, okay, fine. I'll do plus equals 1 like a pleb. Rust doesn't have increment either? Why I don't get why we wouldn't have increment. It's so simple. Then the only option left is C++ if it's in the... C++ equals D. Everyone knows that. Is there a joke in there? Is that why they... That has to be what the joke is, and I just only now put it together. Think it may help us create more bugs. Me. Excrement? You're on a roll, Brian. Garbage may be slightly non-trivial if you have them. Oh. Well, at least in Java, that's why they have, it might be the same in C++, that's why you can do ++i or I++, and that switches. ++i always goes first, I++ goes last, I want to say. Or something like that. Oh, maybe that's just making it more complicated. What am I doing? So this is where we have a choice to make. I need to deal with, once I actually get to the upper border or the right border, that's going to be, I think I have to separate it out like I did this one. See, once it's equal to 0, this while loop will stop. But I might need to do a -1 on this one. Yeah, oh god. I need greater than, I would need like a -2, but I'm going to do greater than or equal to and do a -1. I could probably just do equals, but I'm going to do greater than or equal to, because why not? Writing down. Oh shoot! I need to go. I need to go writing up. I was like, wait, writing down? That's not right. Yeah, I meant to go writing up. So I basically, I want to travel along these like diagonals, like from the lower left of the diagonal to the upper right. And so that's what I'm trying to like implement. But yeah, I need to no, wait, I need to do -1 for the row, not the column. The column does go up by 1, that's to the right. The row goes up by 1, okay, or down by 1. Down is up, that's the conclusion. You're really trapped in a mathematical matrix, I am. And there's no Neo here to save me. If matrix temp I temp j -1 is less than matrix temp I -1 temp j colon. This is where we're checking to the right and up, and taking whichever one is less. So else plus equals add whatever value is to the left or up. Add the lower Well, value on the left is lower, add it, otherwise add up, add up, sure, who cares? Who even puts good comments on their code anyway these days? Nowadays you just copy paste into ChatGPT and ask ChatGPT what it does. Can ChatGPT, I see people ask ChatGPT to write code. Can it interpret code? I assume it can. I'm not going to bother to try and find out, but I feel like it can. Okay, and then once we've done an iteration of this, we're going to do temp I minus equal 1, temp j plus equal 1. It can't, since you have to debug for longer than it would take just write the code. Oh yeah, I bet. If you ask it to write the code. I guess I was asking about like the reverse. If I like copy pasted this code into ChatGPT, would it know what it's doing? That might be more helpful than trying to ask it. I mean, it depends, I don't know. Hopefully I wrote this conditional for the while correctly so that I'm now exactly on the top row or the right column. And I can now do this sort of thing up here. Thank you, Phobos. The alligator eats the bigger one, and I couldn't remember that, apparently. And I need to flip this one, too. ChatGPT is a documentation explorer. Because I want to handle the exactly equal to 0 case separately down here. If temp I is equal to 0. No, wait, I need to tell if I'm in a corner or not. Ah! GPT PD? No, I think I'm okay. If temp I is 0, we can just add to the left. Temp I, temp j plus equal matrix temp I, temp j minus 1. Else, we're going to add it from above. And I'm just not going to do any more checking to make sure my indices don't go out of bounds. Sue me. Now we need to figure out if we want to increment I or j. If I is less than matrix dot shape 0 minus 1 or equal to. No, just less than. We want to increment I. Else, we're going to increment j. ChatGPT. Oh god. I feel like there's no shot this is actually going to work on the first try, but let's just see what we get. see if it yells at us for going out of bounds. Come on. You gonna run? I believe in you. Am I in an infinite loop? I hope not. I can't tell. I might be... This condition might not be right. I think it's not right. Is it right? I think I need a -1. Okay, an error is better than an infinite loop. Use the condition is a shampoo? Line 58, it's yelling at me. Oh, okay. It's not a fan of temp J. Why not? What's wrong with temp J? Does that need to be strict? Let's just blindly make that strict. We got a number. Is it the right number? Okay, the upper left is 445, as to be expected. What is 4445 plus 2697? 4445 plus 2697. 7142. That matches. 4445 plus 1096 is 5541. That matches. Okay. Should we just plug it in and see if we got it right? I think we just send it. This has to be right, you know? There's no way that I didn't write perfect code on the first try. Jay wants to be a real job, but doesn't want to be a temp. Yeah. 400,591. 400,591. Come on. Crap. There's no penalty for a wrong answer. It does make you wait for like 30 seconds or something. But that's all. Okay, what's going wrong here? I have to actually troubleshoot it now. I'd rather it have an error, to be honest. Maybe let's check the first real diagonal. That seems a little low. Is there a 20 there, or... There is a 20 there. Never mind. That's perfect then. What about the one right below it? It's 7385 plus 5. Yeah, well, that's about right. That 11,000 seems a little low. Because it should be these three numbers added together. 4445 plus 2697 plus 5115. It should be 12,257. So I might be making an error on the top row somehow? I wonder why it's only slightly off though. Huh. Can I print like just the first like 3x3 matrix inside of this? Does that work? That looks scary. What is this? I don't know what exactly it did, but it oh, probably because of the way that NumPy structures arrays. Oh, right. Oh, wait. Not right. What? Oh, it's formatting the lines differently. This entire thing is the first row, I think? Yeah. Critical. This isn't really a linear algebra problem. There's a matrix involved, but it's really it's just like a coding problem. Hey, Jed. I've nearly met into the algorithm. I'm getting the wrong answer though. Project Euler is it's a website that has math-themed coding problems, and as a filler for the stream, I've been doing some problems off that. Do you code every day? No. I'm trying to learn how to code. We're in a little competition with Zach. That's a good idea to try, Jed, instead of going straight to the 80 by 80. I did verify, so like from this output, I verified that it was like this on the top row was the first incorrect thing. I verified like that those two are right and these two are correct. So I assume it's something to do with my top row and maybe the right column. But we should test it against the smaller matrix, you're right. Filler, how dare... If I could only have this be me answering questions that people are asking in chat, I would love it, but... Oops. That's just... not gonna happen, so yeah, it's filler. 201, 96, 342, 965, 150, 630, 803, 746, 422, 111, 537, 699, 497, 121, 956, 805, 732, 524, 37, 331. Okay. Hopefully I entered that in right. We can do print matrix up here as well to see. Okay, let's first verify the original. 131, 234, 103, 18, 201, 96, 342, 965, 150, 630, 803, 22, 111, 537, 699, 497, 121, 956, 805, 732. Okay, cool. Now I'm getting 1548. The correct answer is 2427. Chicken or fish, Kirk or Picard, boxers or briefs. Wait, where are those questions from? Oh, yeah, true. Well, chicken easily much greater than fish. I don't like most seafood. I want to try it more though, but I want to like catch an actual fish and eat it. I think that'd be cool. Kirk Picard, no opinion. I never watched Star Trek actually. Boxers or briefs? Briefs. You know, thank you, Jed. This is exactly what I want. The sound of one hand clapping. It's that. Why is a raven like a righty? Is that some Edgar Allan Poe crap? Is he still wrong? The bear shits in the woods, does it stink? Yes. I follow bears around and smell their shits. What path is this taking? Here, 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 here. Yeah, here, here. Is that the same shape? That is, it's getting the right shape. The center is wrong? $746 didn't get added to 770. True. Or yeah, like this is where I went wrong. Now what's happening there? So it's almost certainly this part of the code here that's messing up. Go back up? You mean like in the output? The code up here is completely unrelated. No, this was that garbage recursive function that I tried. This is the actual implementation starting from here. So what I'm trying to do is I'm starting from the lower left part of each diagonal and moving up into the right. And I think it's in that like, oops. I think it's while I'm like mid-diagonal that I'm not doing something right. And that mid-diagonal code is right here. Because if you're right on one of the borders, you have to handle that separately, as far as I could figure. Is this 1038 even correct? Oh, okay, yeah, it is. Never mind. $683 is not. Yeah, how the hell does that work? I guarantee you it's somewhere in here. It's like, it's probably, I wrote this condition wrong. And temp I and temp J aren't stopping when I think they're stopping. Oh, does this have to be and? That made it worse, I think. Or did it? It did fix the upper row, though. No, it didn't. It only fixed that one spot. The 18 is still wrong. I don't know. I'll put it back to or then. I don't think. Well, I don't think or is right though. Yeah, sure, Jed. Because I probably can step through. I just don't know exactly how. Shoot, you need the matrix as well. Here you go. Oh, you're just looking at it? Okay. Because, well, that's just how I'm choosing to travel along these diagonals. I'm just arbitrarily saying that I'm going to start from the lower left part of the diagonal and moving up into the right. I think I'm going to just play around with these conditionals and see if I get a better answer. Well, it's not just left wall or top wall. You also have to worry about the bottom wall and the right wall. Oh, my line to 1214 is different than your line to 12 to 14. I assume you mean like here? No, probably lower. This is when I'm dealing with either figuring if I know by the way that I'm starting this code that I'm going to be on the left wall or the bottom. So I'm figuring out where exactly, if I'm on the left wall or on the bottom, so I know which direction to add from. It's just how NumPy, it's a tuple. The first one is the number of rows, or index 0 is the number of rows, index 1 is the number of columns. So just the maximum row, or sorry, the number of rows minus 1. Yeah, they are the same. I was just like... Oh, yeah, yeah, you're right, I could cache it at the beginning, but that's not my... You're right, that's not a fix. How does the debugger work? I'm scared. I'm going back to normal. Yeah, I mean, that should put a breakpoint, but I don't know how to, like, step through it after. Okay, fine. Maybe I'll stop being scared. Like, I don't know where exactly you would want a breakpoint. Oh, that's right, because I had that. I don't know where exactly to put the breakpoint here. I also don't know how to do one step. At 35? Okay, there's the breakpoint. Step over, continue, step into. Wait, where's just step? Is it step into? Step over? I thought that, doesn't that skip a one? Maybe it doesn't. Just try it. F10. Oh, okay. Oh, okay, okay. So correctly detects that we're on the left side here. Take away the problem so we can see the... What, what does a watch do? It's a thing for it right there. It's the actual value of it, and it's 803, because we're at... It shouldn't be 803 right there. Oh wait, no, that's the, that's not the original matrix, is it? No, it is. 131 plus 201 plus 630. Wait, temp I is 2. Never mind, I'm looking at... Oh my god, never mind. So we're currently looking at this 96 right here. So we're looking to the left at the 201 and up at the 673. We correctly choose the 201. That's not... Oh, 201 plus 131. It kind of takes up a lot of room. I wouldn't be able to see them all at once. So we're now at the 234. Okay, good. And we correctly get out of the loop. And since temp I is 0, oh, would that work? That'll make sense. No? I don't know. Oh, hey. Okay, you're smart. Almost like you do this for a living. Okay, so then we're now at the 234. We want to add the 673 plus 131. Which is 804. And we correctly go into the correct row for that. And since we haven't hit the bottom yet, we increment I by 1 to go a row down to the 630. And start fresh. So we're currently at the 630. We want to add above Wait, what? Yeah. How did that happen? Can I rewind? Crap. Am I fine? Are we just doing... Oh, maybe we're supposed to be on... Maybe I just lost track of where we were. Sure. Hey.
Only if. You don't have to. Just offering it. Oh yeah, so we're on that fourth row now, that third diagonal, I guess, that we're going to evaluate.
Right.
Right. It might actually help when you, if we wanted to print that matrix after every outer while loop, just so that we have that new matrix to look at. Does
I
that make
could. We have
sense?
to start the debugging over though, right?
That's fine because we can
I guess we
skip
can keep it
quickly
and
over
continue
this.
to get to the loop. Okay.
Yep. That way you don't have to like do the math all the time to say, okay, well, where did that number come from? We know where that number came from.
Then if I do continue, it should stop at the breakpoint again. Hopefully. Okay, good.
Yeah, it'll stop every loop. So that loop looks right.
Yeah, we're now on the
Does that look
537
right?
again. Wait, temp I,
962.
temp J.
Hang on, let's look at is that diagonal correct now? 332 plus 96 gives us the 428, so that's correct. And the 1038 is correct as well. Okay, so now go ahead and just do another, run to the breakpoint. Let's check the next diagonal and see if anything got wrong before we step through it. Okay, so now we've got 962 was added to 537 to get 1499, so that's correct. Then we took the 699 and added that to the 537 because that's the cheaper route. So it's 1236 is what we should have.
We have 1231.
Yeah, so that number's wrong. I don't know where that number came from.
Am I just...
Am I doing that math right? 962 is on the left. We added
Probably
to,
shouldn't
or 530. Hang on, 962. Why is 962 on the left? That's right. No, 537 plus 699. It's basically 536 plus 700, right? So it's 1236. So something's wrong there. So now we can go back and, restart. A little green arrow there, I think, is the green restart, correct?
Yeah.
And then you can just walk until you get to that line. So we can skip over the first diagonal and the second diagonal. And now we can walk through the third diagonal. So that first one came out correct, right? We should get 1499 for the first one. Or no, are we on the last diagonal?
We're currently on the 803 that's right here.
Okay.
This is the one
we did the 962 to 537. It gives you the 1499. We did that one already. Correct?
9 to 14. Is that about to happen?
That should have happened already.
We're about to add the 428 to the 803, I think.
I mean, you could put matrix. I don't know if you can put matrix in your watch as well.
The entire matrix is already up above.
Okay.
It's not easiest to see though.
There you go. But we got no, that's fine because go back. We got 1499 there in element 3, so that came out correct.
Okay.
That was the 962 plus the 537 to get that one. So now we're on the 803. Is the current cell correct? Make the locals watch area a little bit wider so you can see the number again.
So we're gonna add the 428, ideally.
We should add the 428 to the 803. So you can look to see which. So that's so if you step over and then step over,
jump down to adding I minus 1, whatever's above it, which is the 428.
Yep. Matrix, yeah, 428 is going to be added to the 803 to give us 1231, right?
That's what we get.
Okay, that's good. That's not the one where it failed. It wasn't this diagonal.
I think it was on the next diagonal, right? Wasn't it 699?
Yeah. Yeah, so the next one should come up with 428 plus 342, which would be 770. Once you get past 52. Then temp I, temp J would be 770.
Okay.
Good. And then the next one's going to be you're going to hit you break out of that loop.
Yeah, and then
you're
we're
going to get 1141.
Okay.
So that one worked okay, right?
Go another row down. In this, wait. Well, that's not good.
Oh,
we just got out of the loop somehow.
So you stopped evaluating?
Yeah, we just broke outside of the outer while loop.
Did you F5 or F10?
I've been F10ing.
Okay. So which case? Oh, you put I as less than shape minus 1. We need to actually go I less than or equal to, right? No, that's not right.
I right now is
Yeah,
4.
do I less than or equal to then, because it didn't actually evaluate anything to the right of that major diagonal, right?
But we,
Is I 4 or is temp I 4?
well, it does need to be less than or equal to, I think. I was being too defensive with not going out of bounds. But
Actually, you need to put while I plus j is less than or equal or less than like the matrix shape 0 times matrix shape 1, right? Or plus 1. Because you need to actually do, you're not doing the bottom half of the matrix. That's all being left as is. For some reason.
is that
Did
going to
something change?
promise me that I don't go out of bounds?
Well, I mean, you're doing the checks in line 40 through 42 to make sure you are checking the bottom and top and right sides, aren't you?
Um, well,
Because if you get I is 5, that's going to be. Because you just updated, or you updated I to 5, or no, you would I to 4. And you,
but let's just, I kind of want to try running it with this little fix and see if I feel like this should work in theory.
what did you fix?
I just took off the -1, or like, basically the same as like less
Okay.
than or equal.
Okay. Well, you have
Um,
to restart it and run it.
okay, I might need to do the same thing for the,
Yeah, do
yeah,
the
actually.
-1 on the end as well.
Hey, Clown Kid,
Because
I
that,
appreciate
that
you
was
hanging
an
out.
or at one point, wasn't it?
See, okay, now
Okay,
I
now
am
we're
out of bounds here. Line 59. Oh, I'm not doing enough checks on this one, I guess. This might be, I looks like I'm nearly there though. And hey, Central.
Well, I mean, the last number should be 2376 plus 331 would be 2707.
Yeah, am I nearly right? It's just this very last one that the correct answer is 2427.
Okay, we're not there. Because you
Oh,
got
we
something
can't.
else
Yeah,
wrong.
we're still wrong. Okay.
Put that -1 back and run it out one more time.
For J?
Yeah. Just undo that last change you did. Is
Still not
everything
right.
right up to that bottom right diagonal? No.
We're not going
That
to get the right
37.
final answer.
So that 3597 at the bottom. So that bottom row, I think, is completely wrong. If you look at the 2304, if we sum the first column, we get 2340, which is 2340, right? 131, 201, 630, 537, 805. We're 2304. Okay, so that's correct. But then the one to the right of that, it should have chosen the 1930, not the 2304. But it chose the 2304. So when it got to the bottom row, it should still be picking either left or up, picking the minimum of those two. Change the
Oh, crap. You're right.
change line 40 to not have a -1 on temp I. So no, we don't want that. We do need a third state, right?
Yeah, I didn't realize that we need to do a comparison for. So if this is if we're on the left side. So here, okay, yeah, and this one we need to do. I guess we can do another if. It's
Well,
kind of
in this
clunky.
case, well, no, you do. You got if we're on the left side, if we're on the lower left of the diagonal, basically you just need to say if we're on the 0th, if temp I is 0, right, then we can only pull from the top. We can't pull from the left. If temp j is 0, then we're on the far right, so we can't, or no, not temp j, but if temp I is 0, that's the first row, right? So we can only pull from the left. If temp j is 0, then we're on the
Right.
left column, so we can only pull from the top. Otherwise, we have to do the comparison.
So yeah, in this code, I'm dealing first with like the left column in the bottom row. So I would need to do, I guess, with if temp j is 0, I just only pull from up, and that takes care of the entire left column. If temp j is equal to 0.
Can't you just start like, I mean, you could treat every cell the same. Just you have to do a check to see if I'm on the left side, pull the top.
I don't want to compare
Oh,
with garbage like data values that are out of range though.
Well, no, because you can tell based on the coordinate you're at if there is something to the left or if there is something above. So if you're in row 0, there's nothing above. So the only thing you can do is pull from the left. Correct?
Right. So I say if
you're on
temp I is 0, then
if temp I is 0, then temp I is 0, then you're going to pull from the left. So matrix temp I, temp j minus 1, or temp j plus equals, and it's that line you have to pull from the left.
All the top row stuff I do down here, but or the top row and right column I do down here. But this is
what I'm getting at is when you're doing your diagonal, when you're doing that entire check, you can do that all inside that while loop. You can do, if it's the left one, if it's on the left wall, pull
inside
from above.
here.
If it's on the top wall, pull from the left. Anywhere else, evaluate both because you do have a top and a left, and then choose the smaller of the two. You don't ever have to check for right wall because you're never pulling from the right. You don't have to check the bottom wall because you're never pulling from the bottom. But when you get to that, when you're pulling from the left, just break out of do you have a break statement to break out of the while loop?
I could break.
So if you're going from the bottom left to the top right, once I is 0, pull from the left and break because you're done with your loop. Because you can't go any higher.
Well, I want to continue if I'm going to be inside of this loop rather than break.
No, you want to. Yeah, you want to.
I mean, I really do with ifs and else.
You want to break there because you're going to actually adjust your I and j to start the next diagonal.
Oh, you're talking about the stopping condition,
right?
For the loop. Why isn't that accomplished with the conditional up here?
Well, because there you're breaking. Okay, so when the temp I becomes 0, then you're making the check at the bottom to pull only from the left or from the top. Okay.
Right. Yeah. I take the equals to 0 case like outside the loop, I guess.
And then while the temp j is less than the right wall, basically.
Right.
So once you hit that right wall, then you're on your last one. Okay.
Yeah, and
So is that first part even necessary?
This part up here?
Like the block at 39, 40, whatever, is that even necessary? Can you just
jump
right
I do
into
the very start of the diagonal? I could.
Oh, you check. Okay, I got you.
I get a little weirded out, like whether I'm in a corner or not, or.
Okay, I was talking about just lumping that inside your while loop. I guess is what I was getting at.
Hmm. Hmm. I think just with how I've already written it, it's already
okay.
Like, I'd rather just not modify it more than I have to, I guess.
Yeah, I got you.
If it's not quite as efficient.
So if your temp I is the left wall and the temp j is not the top, not the j is the column, it's not the Temp I is actually the bottom, right?
When this,
If you're on the bottom row and if you're on the bottom left corner, basically is what you're looking for there, right?
so
Or not the bottom left corner.
this if checks if I'm in the left column at all, including the bottom left corner. Oh wait, sorry. This if is if I'm on the bottom row. Sorry, I said the opposite. It's
Bottom
if
row.
I'm on the
Anywhere
bottom,
on the bottom
row, not including the corner.
Okay. Because then you're pulling from the top.
Then I need to check then. Well, if I'm on the
So
bottom
you're
row
never
here, I need
actually-
to do an if and see which one is lower.
Okay, which you're already doing in 48 through 55, I guess.
You're right. So I probably could make it better, but I trying to also bring the logic for if I'm in the left column inside the while seems like extra work.
Well,
I guess.
that's a simple check to see if temp I is 0, or if temp J is 0 rather. Then you know you're on the left wall. Correct?
Yeah, sure, but
So if temp
I
J is
already have
0,
this.
you're on the left wall, pull from the top. Similarly, if temp I is 0, then it means you're on the top row, so you can only pull from the left. Otherwise, do a comparison of the two different values.
I'm just this makes more sense.
That's an option
to me in
too,
my head,
fellas.
but expand the matrix to the top one fill. Oh, that
Add a 0 row to both ends.
I feel like that would satisfy like, or that. That's probably
But you have
the
to,
best solution. I think that would make me and Jed happy. Cook, hey.
Phobos is quite literally thinking outside of the box.
Yeah, literally. I need to make the same fix. This is.
Yeah,
Oh,
I think
okay.
we're trying to solve this in a vacuum, though. Instead of putting zeros around it means there's something else there.
Right column. And then inside the right column, I need to do a check. You've been doing... Oh, no worries, Phobos. Oh. How am I doing
You
with
could
addition
actually,
here?
for readability, what you could actually do is if you pass in the matrix and the current coordinate to a function called add left or add top, then you could put all those plus equals in there and say, okay, you could actually create little helper functions, I guess, to make it more readable.
What, and do a good job at organizing my code? No way.
Yeah, it makes it more debuggable, because then you can say, okay, am I on the left wall? Am I on the top wall? Am I on the right wall? Am I on the bottom wall? Kind of a thing.
I'll freaking breakpoint. Who even likes those?
Just uncheck it.
It's the same exact thing.
You're just not completing the last value, correct?
I'm still getting like these are the same incorrect values in the diagonal right before.
Why are they incorrect? Let me check. 37, so it's 131 plus 201 plus 96 plus 342 plus 746 plus 422. 37. Hang on, it didn't clear.
Cook, this is a Project Euler problem.
That's correct. And then you add 331, you get 2427, which is your final answer, correct?
The correct answer is 2427.
Yeah, so you're right. You just didn't do the very last. You just didn't do the very last bottom right corner.
Well, hello bells. I don't think people still say that.
You just need to do one more check. Just take that if statement on 63 through 66 and
flawless coding right here.
And make sure that temp I and temp J have been updated to. I don't know what value they're at right there.
I can do temp.
All the way at the bottom, like at 74.
If I do that, I think I'm okay. Or yeah, I mean, I could do it at the very bottom too.
Well, you want it to happen before you change I and J. And you don't want to -1 +1, do you? You want to set them
Oh
both
wait,
to
yeah,
the...
I need to move I and J themselves, not temp I, temp J.
No.
Oh crap. I mean, temp I
You're
and temp
fine.
J might also work, but
You just need them both to be that bottom right corner. So temp I needs to be the shape 0, -1, and temp I, it's basically whatever that bottom right corner is.
I
Or just remove the do you just remove the -1 from the top again? I don't know.
I let's just see if this works,
Sure.
Code by trial and error.
Called out.
Yeah,
Run it, see
because
what
we've
happens.
been working on this Project Euler one. Oh, come on.
That'll put a breakpoint on 5074.
Okay. We'll actually be
Just so you can
smart
see
about
what
it.
I and J, just so you can see what I and J are.
I need to run debug.
Yeah. What are I and J?
Why do I need to? Oh, you're right. Why they're 1 and 0, which is confusing. Do I need to do one step? What? Why am I up here? Continue. There we go. I is 4 and J is 4.
And
That's not.
0, 1,
Wait,
2,
that is
4,
right.
0, 1, 2, 3, that's correct. So then look at the watch, blow up the watch a little bit more so you can see what the values course. It should be 20. Was it 2096 on the left? Which isn't.
Ugh.
IJ shouldn't be 2376.
This is temp I, temp J.
Oh, okay.
We have. Yeah, why is this out of bounds?
Oh, do you have if I -1J, so that's not true. So it should be hitting the next line, right? Is it breaking on 74 or is it breaking on?
What? Now got plus equal 1?
Why is oh, because you did a +1 on 73. Get rid of that +1 on 73.
I thought that I needed it. I guess not. Okay.
I don't think you do. Because you've already done that at 71.
27. Okay.
Okay, so now get rid of your commented line at the top or the other redefined matrix line.
Four two seven 337. Let's see if it works. Cook, were you just on vacation or something? I remember you saying something about a little hiatus. Hope that it went well. What was the number I got? 427337. 427337. Bam! All right, thank you, Jed.
And that ran instantly.
It did. But what about my like 80 quintillion, recursive function calls or whatever? Yeah.
600 sextillion, wasn't it? Or
I don't remember what number you said, but
it's an 80 by 80, right? So it's 2 to the 80th
I think
or 2 to the 79th paths, because you can make 79 different yes. Millions, billions, trillion, quads, quintisex, 604 sextillion.
Oh.
That number.
Okay.
That's how many unique paths there are through an 80 by 80 matrix going only right and down. And you shrunk that down to a lot fewer operations.
Yeah.
Good job.
Thank you. And thank you for the help there, because I was getting really lost in how to debug it.
Used Excel. Wonderful.
Oh.
So they basically worked it backwards, but you did the same thing.
Wow, that's so much easier just using a cell. um,
Yeah, because Excel handles the edge cases for you.
I'm curious about this person. Go to the southeast corner, so the bottom
He
right.
just ran it backwards.
Oh, really? Okay.
Yeah. Everybody's using Java. Where are your Python developers? Come on, guys.
You want to question Purcell and more after this? Yeah, I don't think I'm going to do more coding today.
Dijkstra's algorithm.
I learned that once. I don't have any recollection for how it works though.
When it became quite apparent to me that a brute force attack wouldn't work.
Still not apparent to me. I want to let my computer run for the next like week. With my brute force. This looks Python. It's way shorter than mine. Oh, I'm sure I could have done a min function rather than all my ifs. They also worked backwards. Okay, well. I'm going to maintain that the solution that I wrote is clearly the best and there's no room for improvement. And all these other people's solutions are wrong. What is this? This doesn't even look like code.
That can't be real.
That looks like one of those like meme coding languages that just...
Is that Ukraine? Blue and yellow?
Oh, that flag? Yeah.
Nice. Of course, it was back in 2006.
Oh, you're right.
That problem's been on the books for a little while.
Yeah.
That's just ridiculous. When you see code like that, you're like...
All right.
Cool. Well, I'll let you get back to the next question.
Sounds good. Thank you again for the help.
Hey, now you know how to debug Python.
Yeah.
Today wasn't a total waste.
Well, I mean, we also solved the problem, you know?
Well, there's that little thing too. There's that little thing too. Small victories.
Mm-hmm. All right. Well,
just messing with you. Have a great time.
Talk to you later. Okay. Oh, was there a Mathematica? Is this it? I can't even tell. I don't really know what it looks like Mathematica a little bit, I guess. I don't know much about it. But yeah, I'm definitely a little bit over coding right now, so maybe my coding allotment for the filling in time of day. Hey, Fizzbuzz. No, I don't think I want to play TS 100 again. At least not on stream. It's too much. Sinks back into the shadows. No worries. Appreciate the lurk. Okay, I've been starting to read chapter 4, but let's take from chapter 3. Doing some relativity today. Had a visualization idea that's beyond me. Probably require Blender. Ooh. I know people use Blender for I always meant just like an art program rather than something you might use to help like visualize things, but probably do something cool in there. Okay, right. During the group, we ended with 18. You want to be able to make 3D visualizations like Science, Click, and other physics YouTubers. Mathematica alone isn't gonna. Ooh. You know it's serious when even Dr. Cook is saying Mathematica isn't enough. I haven't worked on it in a minute, but I'm trying to. One of my little side physics visualization projects is to get the electromagnetic field for a tube of finite length, like a cylinder. And so I managed to figure out how to actually make and draw the tube. And I got a little bit stuck on like the vector work. Like it's probably going to take way too long to run as well, but like what I want to do is for like every point in space within certain bounds, add up all the contributions from each of the point charges that make up the cylinder and see what that vector field looks like. I got a little bit stuck on how to actually work with the vectors. I think I figured it out, but I think even if I implemented my idea, it's probably going to be some ridiculously long computation. And it might take forever to actually get a result. Okay, what's up with number 20, maybe? You want to do a finite length cylinder. If you only want E field near the center, you can treat it as effectively infinite and use the Gauss's law. I mean, I was interested in inside and outside. A non-separable problem. I don't know what non-separable means, but I assume there's no way to like simplify it. I think like you could do it for one like octant, and then it should be pretty symmetric. But that's probably not even going to cut it down all that much if it is as big of a computation as I'm thinking it will be. I'm just kind of curious what the field actually looks like. But in chapter like 1 or 2, there's a problem that was similar to that, but you only read about the inside. I'm kind of curious about what the outside looks like too. Consider parallel plate capacitor with different magnitudes of charge on the two plates. Rho RZ can't be written as a product f of r times g of z. Oh, really? I made the cylinder using cylindrical coordinates. That might not be helpful though. I don't know. I guess you're right. It feels like it should be. I don't know. how that separation part would help, but I'm sure it would. I don't really know that much about making visualizations like that, but I've been trying to relearn how to code a bit, and I've been interested in the physics, so I was thinking, oh, well, that's a pretty natural way to try to combine the two interests. So let's look at how the book discusses a regular parallel plate capacitor where the charges are equal. Let's read the original question again. Number 20. A Gauss's law problem? Hmm. Let me just keep thinking about like what the question is actually asking, so I'm still trying to wrap my brain around it. The force charge on the inner and outer surfaces of two plates. So we're saying that this disparity in charge is going to, I mean, my instinct is to say that the insides of the plates will have equal and opposite charges. Whichever one is less will have zero charge on the outside, and whichever one is more will have the extra charge on the outside. That's my initial thought. But you have a question? Yeah, what's up, Critical? Go for it. Right, that's kind of what, I guess what I'm imagining Cook. Like, am I trying to say that there's zero net flux out of a capacitor? Is that why we know the charges inside should be equal? No worries, FizzBuzz. Appreciate the thought there. Like, you know, the at least like impression. So yeah, I mean, that, I just kind of said what my instinct is that there, I would think that the charge, I mean, even just like with a normal, not even like this parallel plate situation, just like in general, they say that, like, I guess even something like this, where the, whichever one has more charge is only going to cancel, like exactly cancel whatever field is coming into it. I need to, I don't know why we'd be able to say there's no flux and then make that. Let me look at criticals. The Gaussian flux that barely skims the inner edges must have zero flux. Yeah, I'll come back to that in a minute, Dr. Cook. I want to think about Critical's question here. How can you quickly check if a proposed value is an eigenvalue of a matrix? Like, if I just let lambda equal 4 and find the eigenvector that we don't know is actually an eigenvector yet. We might need to multiply. I don't know if this is really saving work. I mean, you could find the potential eigenvector from this. And then multiply that vector with the matrix and see if it's a scalar multiple. Determinant of m minus 4i. Oh, really? Probably easier than my thing. Oh, so you understand the first part with proving that lambda equals 4 is an eigenvalue, and you need to find the eigenvector. That part's relatively simple. Let me show you. Eigenthings, I don't even think people named Eugene. Oh, right, because when you said equal to 0. Okay, I get that now, Dr. Cook, yeah. I forget the explanation for why. I just kind of remember the procedure for how you do this. If we know that lambda equals 4, it's the matrix 3, 0, minus 1, 2, 3, 1, minus 3, 4, 5. What do you do? Oops. Ugh, I already messed up. You'd subtract the eigenvalue across the diagonal, like similar to how you initially find the eigenvalues. -1, 1, 5. -4. So this is the original matrix -4 times the identity. Because our eigenvalue is 4, and we want to find its associated eigenvector. So we take the value, subtract it across that diagonal. And now I really hate this Greek letter. I'm going to draw it wrong, I think. C, or I also have to pronounce it Kasai, but I hear every other math streamer say C. I'm probably going to like switch between them, but it's just a random Greek letter. Yeah, Cook, same. This is just a system of equations, basically, where like this is Kasai 1, 2, 3. So what we can do an augmented. We can actually do like the 3 minus 4, 3 minus. I'm explaining this terribly. Let me just rewrite this original equation, but actually do this subtraction here. One. I feel like I'm not drawing Kasai right. Let me do a quick symbols. Where's Kasai? I'm drawing it backwards. Dang it. It's my least favorite Greek letter, but at least do it the respect of, you know, drawing it the right way around. It's so confusing. It's like that? No, it's not. It's a stupid letter. I hate it. It's like that. Okay. I'm calling that good enough. And it doesn't have to be that Greek letter. That's just the one that is often used, but it doesn't have to. You might have been taught to use a different letter. But anyway, this is just a system of 3 equations with 3 unknowns. We can make an augmented matrix out of this and solve that using our normal row operations. I'm harping too much on the setup here. The real point of how you find an eigenvector is you take your original matrix, subtract your eigenvalue across that diagonal, and set everything equal to 0 and solve that. That's really the biggest like point here. So I'll go through and solve this. We'll take row 1 and we'll send it to -1 times row 1, just to get that as a pivot. Writing Chinese is easier than writing Kasai. True. Kasai. Okay, thank you for agreeing with me, Peach, because I feel like I was going crazy with hearing everyone else pronounce it differently. And welcome in, TC Fullerton. All right, let's get rid of the 2 in the -3 now. So we'll do row 2 and send it to row 2 minus 2 row 1. Row 3 will become row 3 plus 3 R1. And sometimes they also just, because the 0 column is never going to change, sometimes they do just chop it off and imply that there's all zeros there. I'm going to write it all out though. -1 minus 0 is 0. 1 minus 2 is -1. 3 plus 3 is 0. Or minus 3 plus 3 is 0. 4 plus 0 is 4. 1 plus 3 is 4. That's can't be right. I did that wrong, didn't I? Matrices are the worst. It's -1 minus 0. That's right. Okay. So I can already see we're going to get a row of zeros here, but that's fine. That's actually to be expected. Whenever we get an eigenvector. Use capital Kasai in a paper once was a very bad choice given how someone looks to a fraction. Oh yeah, true. It's a little hard to read the matrix notation in Twitch chat critical, but I think it looks the same, I think. I'm gonna multiply row 2 by -1. Actually, no. Well, no, yeah, let's get rid of row 3 entirely. Row 3 is gonna become row 3 plus 4 times row 2. And I'm gonna draw a crazy arrow and come all the way over here to make sure I don't get cut off by the problem. Excuse me, headphone. Oh man, I'm at my cords limit. I'm not being cut off by the chat, right? No, I'm not. 1 0 1 0 0 0 0 -1 -1 0 0 0. Don't be scared by the row of zeros. That should always happen with an eigenvector problem. Let's multiply this through by -1. And then we want to get rid of that one right there, right? So row 1 is going to become row... Ooh, wait, no. We get rid of that one. No, wait. No, this is just done, isn't it? I'm pretty sure it's just done. I'm just bad at matrices. So let's bring it back to system of equations. And so we have a free parameter here that's x3. We know that x1 is equal to negative x3, and that x2 is equal to negative x3. So Kasai... Ugh. Oh, yeah. That's not going to match. Actually, is it going to match with the answer? Let me look at what you put for the... Okay, good, it will. What if I show you? Sure, you can show me something. It's going to be minus x3, and just x3. And we're allowed to choose anything we want for x3, so the book chooses -1 just for fun, so we get 1, 1, and -1. But I think the point of eigenvectors is that you don't, like, it could be, you could make a different choice of x3 as well. I don't know if that's the point, but you could. Yeah, sure. Let me look at that work from your tutor. Because my linear algebra clearly sucks, so if your tutor is better at it, it'll probably be better to look at that. He left the session because he needed to go. So this is the same setup as I have. Well, oh, wait, what? That's a different way of doing it. That's equivalent. I haven't seen this way of getting eigenvectors before. It works. Well, yeah, it's because I'd rather just like I skipped over things. I'd rather just do it the way that I was like taught because my memory was so weak that I just memorized the few things that I know. But yeah, if you prefer to do it this way, this is completely valid. Nothing wrong with it. Yeah, the only thing, like, I guess is what I did is even extra work, because what I do is I basically subtracted this term over to the left side, and I factor out the x1, like the x vector. But this is completely fine to do it this way. Do you need to do it really fast? You prefer my way, but you need to do it fast, so you want to learn this way? Yeah, Gaussian illumination is super annoying. This is still row reduction. It's not always going to be fast. Like this one, you have a little bit of a nicer situation here. But you still have this system equation to solve by hand. So no matter which way you do it, my way or the tutor's way, like there's no way around doing some type of system to my knowledge. Yeah, sure. So like if I was a student doing this on a on my homework or on a test, I wouldn't show as much work as I've shown you. I would be able to do a lot more of this in my head, but if you need me to take my cam off again, let me know, but at some point you just gotta solve a system to the best of my knowledge. Hey, Dwarf Keck. It's going good. How about you? Also, x1 equals minus x3, x2. 1, 1, minus 1. Yeah, it's what Cook is saying. Any vector that fits this format is an eigenvector. I could have let x3 be any real number I want, and it would be a valid answer. The book chose to take x3 equals to -1, so you get a vector that looks like that. If I was doing this personally, I would have chosen +1 probably and gotten -1, -1, 1. But they all point in the same direction. It's really the same vector, just it might be facing a different way, or it might be like, it's a difference between choosing that vector and that vector or that vector. Like in the linear algebra sense, they're really the same vector because they're scalar multiples of each other. It's a little bit arbitrary which exact one you choose. Yeah, exactly, critical. Lying on the couch drinking Pepsi, nice. Guess I'm too smart for math. Congratulations. Exactly. Critical, depends on the free variable. Besides, okay, yeah, besides 0. 0 is technically also true, but it's not interesting. 0 is the only, like, you know, technically wrong answer. It's still a right answer, but it's not, your teacher is going to mark you down if you choose 0. When you say do it like this, do you mean doing it my way versus doing it the tutor's way? Because our two ways are completely equivalent. It's strictly wrong. Oh, that's a definition thing. I mean, I can believe that it's wrong, but like it's one of those things where we just arbitrarily. It's the same thing as like 1 isn't prime. It's like it really like we just exclude it for stupid reasons. Well, not stupid reasons, for probably for good reasons, but I don't know. It's like we exclude because it's inconvenient, I guess. I don't know. That's my assumption, at least. As someone who barely knows linear algebra, so maybe I shouldn't have an opinion on it. But Dwarf, I mean, do you want to know how to solve? Well, I mean, we solve like fractions. I can try and talk a little bit about that if I can hear what you mean more, but. But the point is, the 0 vector really is an eigenvector of every single matrix. Unless you arbitrarily exclude it. I don't know. Isn't it? Because it's a vector that becomes a scalar multiple of itself. It's still 0, right? I could be saying something that's wildly. I'm probably saying something that's like wildly wrong, but like, I know it would break a lot of things if we included it. But technically, it fit the definition if we just didn't throw it out separately. I know it like it's for the better that it's out, but it's not excluded in like a natural way. We just have to specifically say, no, you 0 vector, get lost. What grade is higher than F? Well, I mean, I would think D, but I don't know if you mean like lower or thinking about higher in the opposite way. Or I'm thinking about higher, I don't know. F plus? Yeah, that's you? Okay. You're just chilling, feel free to chill, but if you actually want to know about something, please do let me know. All right, let me clean off the whiteboard and then we'll, I guess, get back into Purcell unless there's another question. Okay. Chemistry is harder for you than math? I'm definitely not a fan of chemistry. Way too much memorization. Well, my thing about one being prime or not is that I'm also very uneducated in this, but I think one is just excluded from being prime because it would break a lot of the definitions and theorems we have about prime numbers. So that's why to me it's on the same level. Like it otherwise fits the definition, but because it breaks all these other things that we built, we exclude it because we would rather exclude it the one time than like exclude it in every case where it would come up. Do I mew every day because my Riz is on max? I don't know what mewing is, unless you mean like a cat goes meow. Hey, Surendra Singh. Where you put your tongue at the roof of your mouth to have a stronger jaw over time? So you make your jaw and your like tongue fight each other? Huh. I okay. Oh yeah, Riz I knew. It took me forever to realize that Riz is a shortening for charisma, but who were born after 9/11, I can tell. uh. 2008? Oh, geez, you're young. It's unfortunately no too much. Dude, even when I was in high school, I didn't get the memes that my friends were saying. I feel like I've never been in tune with that. I remember 2008. Skip. Oh, God. I've heard skippity. I have no idea what it means, though. Ugh. Okay, well, let me... For number 20 here, Dr. Cook earlier put a thing in chat about making a Gaussian pillbox, and I couldn't quite understand what visualization was happening. I found the message. I'm 27. You know about Skibbity or Ohio? Oh yeah, specifically with Ohio. Yeah, I don't know what the Ohio part means either. Skibbity comes from some internet show called Skibbity Toilet, and apparently means bad. Oh, okay. That Gat Grimace Shake. I mean, not it's kid speak. I don't know. It sometimes means bad. It's a nuanced word. Okay, but Cook, with this like Gaussian surface that you're saying, do you mean this Gaussian surface fills the entire area between and just a little bit past? Oh God. Like the inner edges of the plates all around and just a little bit extra on the sides is what I'm imagining. It makes sense intuitively that should have 0 net flux, but I don't know why we couldn't have a field line flying off to infinity. A little bit extra on the sides like me. Drop the two thickened plates. It's a cylinder which extends just above the outer surfaces. I mean, I know what edging is. Gooning, I feel like I've heard the word. I don't know what it means though. I don't think I want to know. Yeah. I'd be pretty happy if I lived my life without learning that definition. Okay, so that's my capacitor. Just being a porn addict? Oh, okay. I mean, that's not so bad. General relativity, my free time, not watching TikToks. Dude, TikTok, it's terrible for you. I do a lot of stuff that's terrible for my brain, so I can't judge, but I specifically don't go on TikTok because, like, I feel like that's one of the worst things that you can do for your brain. The Gaussian surface is a cylinder which extends just above the outer surfaces. Really? So it's like this? I yield to your born in 2008 knowledge. So, like, just to say it, my intuitive theory for what the answer is that if we take Q1 greater than Q2, I think what we have is Q2 of charge inside minus Q2 charge up here. And then whatever extra charge is on the outer surface, and then there's 0 charge down here. That's what my instincts are telling me. And it'd be like spread evenly, like horizontally, I guess. Well, the outer might not be spread evenly, but the inner will be spread more or less evenly, I think. We got confused about the terminology? Oh, okay, okay. So you're saying a cylinder like that. Okay, that makes sense to me that we should have 0 flux in there. But I was imagining that we would want to prove something about a Gaussian surface. Maybe I'll do it in green. Or say something about a Gaussian surface that was more like this. And the thing I was worried about is whether a field line could like fly off out of nowhere or something. It shouldn't, but that's like, I don't know how to say that it can't do that. Or if that's just obvious, I don't know. But it can't be right. That charge distribution will produce a non-zero electric field inside the conducting plates, which cannot be. Wait, I don't see why not. That Gaussian surface has zero flux, then zero net charge. The inner surface equal and opposite charge. I don't see any surface now you need to consider the outer. Well, if the leftover charge on the top, outer, it does have a flux, but it's going like up and out of the top plate, not into the conductor, I thought. Because the charge inside a conductor is, or the field inside a conductor is zero. I didn't view it as being an issue. Consider the charge distribution given on the board currently. That is 3 surfaces with charge, 1 surface with no charge. Sigma formula for the electric field due to plane of charge. Sigma over 2 epsilon naught. Calculate the electric field in between the plates. Do you know what Giat means? I've heard it before. It's a weird way to say God or something? I don't know. Oh, you're saying that this... Oh, okay. God damn, that makes more sense. So, Cook, what you're saying is that the field from the plane up here is going to add to the field on the plane on the bottom surface, so there's going to be some field lines like that. Or, you know, maybe the opposite way, but who cares? Like you're saying that, I feel like it shouldn't because of the way that conductors work. Like, even if we have... Oh, I guess they're the same charge. In the conductor that I'm used to, we have like all negatives on this side and all positives on the other. Is that the issue? Because minus Q2 and the absolute value Q1 minus Q2 have the same sign. Okay. Violating the way conductors work, that's my point. Okay. I guess I'm on board because I was just kind of applying an assumption from earlier in the book. But yeah, I see now why that assumption doesn't hold. I don't know what to do with this now, but there cannot be net charge inside the conducting plates, so the charge has to distribute over the 4 planar surfaces. They must also do such a way that the E net field can write these conditions down and just solve. Charge has to distribute over the 4 planar surfaces. It must also do this in such a way that the net E field inside the conducting plates is 0. Yeah, that's like a chapter 1 thing for a plane of charge. We can definitely use that. Cannot be net charge inside the conducting plates. And starting to figure out how to translate what you're saying into equations. Sure. QA plus QB is Q1. Sure, yeah. QC plus QD is Q2. Two more equations to solve for the Q's. Okay. And that goes to what you were saying. So we should have that QA equals minus QB and QC equals minus QD? Or... Yeah, so if yeah, that's not right. So I did exactly what I just said. That's two separate systems. They're not actually linked. So that, okay, that's what I was going to say at first, that QB is minus QC. I started, I guess I threw that out though, because I guess that part is still true. then the fourth condition comes from the field inside the conductors being 0. What has to be true for the field inside them to be 0? Seeing sigma over 2 epsilon naught or so. Hey, Husky. I'm in America. And Harsh, what do you think of Indian solving skills? I don't know exactly what that means, but the people who have come into the chat and asked about like the JEE Advanced, those questions seem super hard. I'm not seeing it, but let me, Husky's asking about the integral of ln of sine of x. Let me see if that's an insane one or not. Is Indian education system too old as compared to us, Europe? I'm really not sure what that means. I don't know anything about India's or Europe's education systems, though, to be honest. Husky, where is this integral coming from? Because Wolfram is giving me a weird function that usually means that I can't do it. I mean, I can try with the bounds too, but if I can't do the indefinite, I probably can't do the definite. Unless there's some kind of, because of the bounds don't really have symmetry here. Oh, Ralph just does that numerically. Yeah, okay, I assume that's some kind of challenge integral or something that I probably can't do. Yeah, Harsh, I've had a lot of people ask me JEE questions. I usually struggle very hard with them. Yeah, it is, Husky. Oh, well, welcome in, Sai. Hey, $10. Getting home long. Oh, geez. That is a long day. Glad you're finally home though. Dr. Who was just helping with this problem 20, and I'm like stuck on this very last bit. QA is too large. Enforce the electric field inside conducting plates must be 0 using the sigma over 2 epsilon naught result. And sigma is what? Total charge divided by the area? Oh, I love a good blue moon. I think I just have a pale ale in the fridge right now, though. I assume that's directed towards $10 anyway. Yeah, I mean, it's just like it. I'm trying to relate sigma over 2 epsilon naught to the constants that we have. And I guess you would do that by sigma equals like charge divided by area. But I don't know how we would want to add up these different planes to make 0. Is it literally just all 4? Well, like, and knowing that the A's and the 2 epsilon naughts are going to go away. Like this? That's supposed to be a D. I feel like each of these individually are equal to 0, but if you add two things that are equal to 0 together, they also sum to 0. Which plate? Ah, you're right. Okay. QA and QB oppose each other. Well, QA opposes all three of these if we're inside of this top plate. So are these all minus signs? Make a point inside the bottom plate. Oh, I mean, okay, I can do the bottom plate too. I assume we just get the opposite where all three of these are opposing QD. So it'll be that. Well, don't they have opposite charge? Okay. Hey, glass chains. Yeah, feel free to try it. All right, let's just rewrite the fourth equation to get rid of all the constants. This is annoying to solve for. I mean, I guess we can, okay. QA plus, well, it's the best way to solve this. Maybe just, I just plug things, I just sub into this equation from these as much as I can, right? It's like I can make that minus Q1, well, minus QB. QD is Q2 minus QC. Then how can we get rid of QC? We get a QB, but that doesn't really help. Ugh. I hate systems. I mean, just type the question, glass chains. Yeah, Finlux, to make sure that there's no field inside the conductors themselves. Basically, this uses the field due to a plane, where sigma equals charge over 2 over A. And so this equation is from considering the field inside the bottom plane, where Q sub D is being opposed by all the, like, QA, QB, QC are all pushing in, and QD is the only thing pushing up. So QD has to exactly oppose all three of these in order for the field inside to be 0. Just pop it into Wolfram. Yeah, I know I should be able to solve it by hand. I'm just like mentally slowing down. I'm kind of annoyed because I should be able to do this a lot quicker than I am. Wait. Oh wait, I'm getting my Q's mixed up. I can solve for QC right now, can't I? Like that. And we know what QC is, so QB is the minus of that. Which means that yeah, it's weird to think about when one Q is a variable and the other Q is a constant that we're allowed to have as our answer. That's the average? Plugging that into there. I guess this will be the negative of the average. I guess, so on the outer edges, we have the average of the two charges. And like half the difference of the two charges. What is it? Like half the difference. Whatever excess charge, we take half of it. Oh shoot, the problem is covering up the less of the work. That's weird. I assume this is the right answer though. It seems pretty like symmetric. Let's look at the answer. It should explain a bit more about like why, I think. Ooh, first solution. The second solution is to be something stupidly simple, I bet. The charges on the inner surface are therefore equal and opposite. Okay, I'm bored with the first paragraph. I prefer the alternative one, but I think I'm on board. We now claim that the charges on the two outer surfaces must be equal with the same sign. Consider a point P inside one of the plates. The field is 0 at P. Two oppositely charged inner surfaces of the plates produce zero net field at P. Two oppositely charged. No, I don't have the Wolfram subscription, Husky. The two outer surfaces of the plates. Inside one of the plates. Because they lie on the same side of P. The two oppositely charged inner surfaces of the plates. Okay, yes. Now, okay. I had to read this at least 5 times, but I understand this sentence now. The two outer surfaces of the plates must therefore also produce zero net field at P. Okay. This will probably simplify the system of equations. I see a lot of Indians here, so I think streaming when there's afternoon or evening. Oh yeah, Husky. I think that would be a pretty awful time for me, though, is the issue. I have to stay up very late or get up very early. But yeah, let me see if I can find the page. I didn't really expect it. But I think India is like the single biggest country for the YouTube stream for people watching. Let me see, where is the... Yeah. So India is 19.2% of the audience, US is 16, and then everyone else is like 1% or less. Which it's... I don't understand why, but I appreciate people being here. And it's not understanding why. I mean, like with the time zones. I just don't know the JEE advanced like questions. They're so hard. Like I'm not particularly good at answering them. Yeah, you're right. It probably will be better if I streamed at a better time for India, but I'm not gonna mess up my sleep schedule to do it. My sleep schedule's already getting a little messed up and I need to like fix it, but India's education system kills creativity. Yeah, I mean, I can't say know anything about it, but I think there's a similar attitude here in America where standardized testing, people kind of feel it puts you too much in a box. I'm not sure if it's a similar thing in India, but like like teachers are often forced to teach a certain way and only teach certain things. And students like kind of have to do a certain thing, so. Thanks Dr. Cook for looking at glass chains problem. I've tried a few of glass chains problems before, or I've looked at them, but glass chains is kind of beyond me, so I'm glad that you at least are around and were willing to look at it. Since these two surfaces lie on opposite sides of P, must have equal charge densities. For surfaces, surface charges therefore take the form shown in figure 12.56. Q1 is equal to, oh yeah, they simplify this a lot. Q out. I should have gotten the exact same thing for QA and QD. Did I do that? I get opposite signs for QA and QD. I think because of how I set up my system, that might actually be that significant of a difference. Am I looking for help on the ceiling? I mean, right when I'm looking off to the side here, I'm looking at my whiteboard. I do absolutely look at the ceiling a lot too. I don't know. It helps me think, I guess. I got kind of the right form. I think there's a slight distinction with how the systems. I think in that fourth equation, I might need to flip a sign. But I got the right form for the answer. It's just for one of my Q outs, I got a flip sign, whereas they should have the same sign. That's not the end of the world. Second solution, it's only 2 paragraphs. Let's see what the easy way was. Oh wait, let me... Okay, yeah. We can solve for the charges on the 4 plates by letting this 4 surface densities be sigma A, sigma B, sigma C, sigma D, and then explicitly writing down the electric fields in the various regions. Then explicitly writing down the electric fields. The field due to an infinite sheet has magnitude sigma over 2 epsilon naught. Have you seen Jackson for electrodynamics? I've heard of it. I've heard that Jackson is like the boss battle for physics textbooks, like extremely difficult, but also like the highest level. I don't know if that's like, or maybe I'm exaggerating it, but like I've heard it's not to be like taken lightly. No, I definitely haven't tried it. Purcell is the only physics book that I've studied out of. I majored in applied math, and I had to do 2 semesters of calculus-based physics as part of that. I don't recall my physics professors ever actually using a textbook. They kind of, or it's not explicitly, like I didn't have to get a textbook for this class, I don't think. They probably pulled a lot of their material from a textbook, but I don't recall which one. It was nothing nearly as advanced though. Like you didn't need vector calculus for any of it. E equals 0 in the region inside the conductor tells us that minus sigma A plus sigma B. Right? And right. Sigma A equals sigma D. Huh. Oh, well, okay, you still have to... This is only the first, this is a different way of doing the first part of the first solution. You still have to do the system of equations bit, I think. Okay. I didn't mean to stream for this long again, but I'm probably going to similarly like try and hold out until Penn Center starts up complex variables. So maybe let's pull another physics question here. It's 20, I want to avoid the ones that I called out though. That's probably not a big a deal. I'm still just looking at what 22 is though, so let's just take a look at 22 here. Capacitor consists of 3 concentric cylindrical shells with radii R, 2R, and 3R. They're at the same potential. Hey, Sins Fact, if that's your name. If root of quadratic equations are sine x and cosine x, what does it mean for the root of a quadratic equation to be sine x and cosine x? Prove a squared plus 2ac equals b squared. So, okay, maybe I can figure out what this means. I'll paste it over to the YouTube chat. Well, I can even put it on the screen. So I'm going to try and set up an equation here, and you tell me if this seems somewhat accurate. So if the roots of a quadratic are sine x and cosine x, I think that means we would need like some kind of second variable. Like we'd say that y minus sine x times y minus cosine x is 0. Because having like x minus sine x makes no sense to me, but If it's some other variable like y, then and sin x and cosine x are constants. Wait, what's the second thing to prove? Oh, okay, never mind. A squared plus 2ac equals b squared. So if we multiply this out, what do we get? That's not right. Let me not do too many steps at once. We have y times negative cosine x, so y cosine x minus y times sine x plus sine x cosine x. So we can factor the y out of these two. Oh my god, what am I doing? So I think here we would have a equals 1, b equals minus sine x plus cosine x, c equals sine x cosine x, and we plug into like the left side here and hope for the best. I mean, we might need to put in like some kind of constant in front there or something. Maybe not. Like 1 squared plus 2 times 1 times sine x cosine x. Oh, I think I see it. Maybe? Do I? 1 squared is 1. 2 sine x cosine x is the same as sine of 2x. Actually, maybe I don't see it. Oh, okay. Yeah, the alphas make me feel better. So I'm doing basically the same thing. I just have a y instead of an x. But it looks like I did interpret you right. Oh, okay. Yeah. We're nearly there. I'm gonna take away my last step though. So I'm gonna label what this is. This is a squared plus 2ac. It's equal to that, and we're going to simplify it a little bit. 1 plus 2 sine x cosine x. And now separately, let's work out what b squared is. Minus sine x plus cosine x squared. So negative 1 squared is positive 1 times something is that thing. What we really have to do is multiply out sine of x plus cosine x squared, which is sine squared x plus 2 sine x cosine x plus cosine squared x. And then by the Pythagorean identity, sine squared plus cosine squared is 1. So these two combine to be 1. And then we still have that 2 sine x cosine x. I forgot the 2. And look, this happens to match that exact thing. So b squared is equal to this, and this is equal to a squared plus 2ac. So I'd say that's my proof there. So the side that it took me a minute to figure out what was happening with the problem since, but do you understand what was happening there? Oh yeah, everything I know I learned from Husky. Oh God. I've seen that integral before. What's the trick for it? I need to see. I want to let Wolfram do the indefinite integral here because I don't want to do the complete wrong thing here. Solve it graphically? Are you talking about like a Riemann sum or something? Or do you already know the answer to this question, or why are you saying that's really easy? No, you're good, glass chains. Chat is slow anyway, so may as well. I'd rather have you two discussing that problem than it be empty, so. So I don't know what you mean by solving it graphically. Unless you mean some kind of numerical method, but I don't think that's what you're talking about if you're getting like pi over 2. I've seen this integral before and I maybe have done it. I want to. It's not necessarily easy though. So I want to let Wolfram give me the first step at least. That's an annoying integral. I think I can do it though. I think there should be a different way to do it. It's maybe a little more straightforward. Oh, there's a black pen, red pen on this. Of course. Let me just see if black pen, red pen has a different idea. Nine years ago. Oh. Well, the solution on the right side seems pretty easy. I don't know where the left side is going. I don't know if it means that to be a dead end. Okay, so you're doing the integral of the square root of 1 minus x over 1 plus x from 0 to something. To 1? To 1. So first thing I'm going to do is use an exponent rule to write these underneath one big square root. And then I'm going to copy black pen, red pen here and multiply this thing by 1 minus x over 1 minus x, because that's just 1. And you're allowed to multiply by something like that. And so what that is going to do for us is give us from 0 to 1, 1 minus x squared on top over, this is the difference of two squares, 1 minus x squared dx. And now we have, on the numerator, we have square root of a square. So let's simplify that to be 1 minus x over root 1 minus x squared. And now what you do is you split this fraction up based on the numerator. This is way simpler than the Wolfram-Malthus method. 1 minus x squared dx. That is just arcsine. Of x. This we do a u sub for. And it's going to become like the integral minus a half 1 over root u du. I need to see a bit more work. That's like u to the negative 1/2, and you apply the power rule to it. So you multiply by 2 root u. Right, okay. So the 1/2 and the 2 cancel, there's still a minus sign in front, and u is 1 minus x squared. So minus 1 minus x squared, and we're writing x from 0 to 1. One becomes pi over 2. Oh, yeah. Arcsine of 1 is pi over 2, yeah? 1 minus 1 is 0. Arcsine of 0 is going to be 0. I think we're getting a minus 1, though, aren't we? Because 1 minus 0 is still 1. I guess you're getting a plus 1. You said only minus 1 was an option, though? Did I mess up a sign here? Oh, it is plus 1. No, that's what I said. Is it supposed to be plus 1? Let's look. Oh, see glass chains? It's supposed to be minus 1. What sign did I mess up? From 0 to 1. Pi over 2 minus 1. Why am I getting plus 1? Ugh. Or, no, it's supposed to be minus 1. I'm getting plus 1. Oh, I see it. We get a negative sign from the u sub, but we already had a negative sign from the integral. So they become, it should be plus. I was doing the u sub a little, I was doing a little too much mental math there, I guess. For my own good. Wolfram Alpha does it such a complicated way. I'm glad I looked at that red pen video. And so yeah, for anyone who's new, I dual stream to Twitch and YouTube. So if you meet talking to people who aren't there in the chat, they're probably in the other chat. Can you prove the Riemann hypothesis? I wish. I would love to be a millionaire. Dude, black pen, red pen to save the day. You would love to also? Yeah. All right, I guess let's maybe get another physics problem. Oh yeah, so again, this cylindrical capacitor one. Three concentric cylindrical shells. Oh God. How do you have a capacitor that's a shell? Doesn't it have to have some type of thickness? Or maybe it does have a thickness. Maybe we just don't care about the thickness. The inner and outer shells are connected by a wire, so they're at the same potential. Yeah, I mean, I'm sure not learning from the conversation that Dr. Cook and glass chains, because I wasn't really following it. But it looked like a good conversation to follow if I actually had the background for it. Final. A battery transfers charge from the middle shell. X to the fifth plus x to the fourth plus 1 equals 0. Find x. It's going to be irrational or imaginary. So I would prefer not to. Like, is that like a meme question, or are you actually asking? Like, what are the answers? Yeah. He has a similar beard cut like Walter White. I need to see it. I don't remember how it looks, to be honest. This isn't gonna... Okay, so sometimes when I Google things that have nothing to do with my location, Google tries to say my location anyway. Let me... No, I don't! I mean, if me with a goatee, I think it's similar, yeah. But like... Like, just like the goatee part, yeah, sure. But, you know, I have all this stuff on the side. I don't know. His mustache is way better than my mustache. And the little, like, connectors. It's nice facial hair. I wouldn't mind having it, but I think his is a bit more glorious. I don't know. Wait, baby? What? What is this? This is disturbing, you know? Anyway. Yeah, since back, sorry, if that was a real question, I don't know how you would do that. Yeah. Dude, oh my God, like last week I looked up ellipsoid volume, like the volume of an ellipsoid, of like an ellipse but in 3D, and prostate comes up as a suggested thing. And I learned that day that apparently you can approximate the volume of prostate as an ellipsoid. There's actually like medical papers on it, so, you know, learn something new every day. Yeah. It's like, I really don't know how you would factor this thing. Because Wolfram gets the real root numerically. Imaginary roots, I don't know how you would like get them. Square root of 69. Look at that. Oh, yeah, okay, you're putting a different problem in chat there, since fact. Find roots of equation 2 sine theta plus 3 divided by sine theta plus 7? Oh, God. Okay. That's another one where I'm going to write on the board, and you tell me if I'm interpreting your problem right here. But yeah, I think Tertar is saying, I think I agree with Tertar, that it's going to be a quadratic. So what do we have here? Is Fenbox lurking? Maybe. See if Fenbox appears. 2 sine theta plus, was it 3 over sine theta? Plus 7 equals 0. All right, so is this the right interpretation for the equation that you said? Like 3 divided by sine theta like that? It's just the main thing that I wanted to make sure was right? Okay. Hey, Reed Kumar, prove that all angles of a quadrilateral are 360. I don't know how to do that off the top of my head, but I could look into it after this problem here. But I'm not doing Sudoku, if that's what you're asking. So I would start this problem by, well, I would really start it by noting that we can never accept any solution where sine theta equals 0. We've been allowed to divide by 0, so if we do get something involving sine theta equals 0, we have to throw it out. But barring that, let's multiply each side through by sine theta to get rid of that denominator. We're going to get 2 sine squared theta plus 3, because the sine theta cancels the sine theta, plus 7 sine theta equals 0. This does factor. So we can factor this like these sine thetas are x's. And when there's a leading coefficient that's not 1, I usually set something up like this. We know it has to multiply to 2, so there's only 2 options there. And we have to have a 3 and a 1. we want the 3 to multiply with the 2 sine theta. So we want the 3 over here. Because we get 2 sine squared theta, 6 sine theta, 1 sine theta is 7 sine theta, and 3 times 1 is 3. Okay, so that's how that factors. Oh yeah, Taratar, that's a nice idea. Using right triangles. All right, so now we split this into 2 separate equations. 2 sine theta plus 1 equals 0, and sine theta plus 3 equals 0. Well, on the right here, I'm going to start with this one first because we can subtract 3 to the other side, and this equation is never true. There is no value for theta because sine is locked between -1 and 1. -3 is outside of that range. So we don't get any helpful solutions from the right equation. From the left equation, though, subtract 1 over and divide by 2 to get sine of theta as 1/2. And this is, now we take the arc sine, but we're going to get technically infinitely many solutions unless we have a, I don't think we have a restriction, do we? Okay, and look, we're save it for Penn Center, Cook. I'll catch up with the Twitch chat in a minute. Okay, so I don't think we have a restriction on theta, unfortunately, so I'll get all solutions for theta. So if we take the arc sine of each side, we have to be a little bit careful. We'll get theta equals arc sine of 1/2, or of -1/2. There's 2 places in the unit circle where that happens. It's oh gosh, I'm gonna mess this up. No, I'm gonna bring up a unit circle. I know for a fact that I'm gonna say the wrong angle. I could work it out, but I don't want to do it quickly, and just give me the unit circle. Hey Joseph, -π/6. Oh, I mean, I could do that too. You're right. I'm going to use 11π/6 to stay on the 0 to 2 pi like cycle, but -π/6 is equally as valid. That's an easier way of doing it, actually. Okay, so 11π/6 and 7π/6 is what we want. So 7π/6, 11π/6, but if you take the arcsine of each side, you need to do plus 2k pi, because technically any equivalent angle to 7π/6 is also a solution. And we represent that by doing a 2 pi revolution around the unit circle. And k is any integer. Or it might also be written as like k is equal to like minus, oh my gosh. Instead of doing like the fancy notation with k belongs to fancy z, some people also write it as like, they just write out the pattern. The important part is that k can be any integer. So these are our 2 solutions for theta. Well, the 2 starts with the infinite many solutions to theta. None of them break our condition that sine theta equals to 0, so we don't throw anything out. There's a part 2 to the question. Which is 2 cosine theta plus tangent theta. Which is kind of a random thing to have to calculate, but we can. So if we let theta equal 7π/6, this will also cover any plus 2k pi like revolution. 2 cosine 7π/6 plus tangent 7π/6 Unit circle. If sine was -1/2, that means that cosine here is -√3/2. Tangent is going to be positive. It's going to be 1/2 over √3/2, which is 1 over √3, which is √3/3. So it's -√3 plus √3/3. Is there a simplification for that? Get a common denominator, I guess. -3√3 plus √3/3. Minus 2√3/3. I guess it's the simplest form that we can write that in. And then we do the same exercise, but for theta equals 11π/6. Oh, there is a restriction on theta. Okay. Thank you for telling me that. I'm doing the extra work. If theta is between 270 and 360, though, we take only 11π/6. No plus 2k pi. So I would say this is your answer here for the first part. And ignore this. We can still plug in 11π/6. 2 cosine 11π/6 plus tangent 11π/6. Cosine 11π/6 is positive √3/2. Tangent 11π/6 is negative. It should be √3/3. -1/2 over √3/2. Right. So it's √3 minus √3/3. Get a common denominator, so that's 3√3/3. So it's 2√3. I'd say that the answer is 2√3/3 for the part 2. Okay. I had the unit circle on my ceiling? Exactly. Correct? Awesome. Okay, let me get caught up with what's happening in the Twitch chat here. Oh yeah, you get back from your trip. A few long days at work, so I'm just vegging out. Just pre-calc and stuff. Brain may not be to Purcell or Lunesto. This week I've been helping an engineering student who's taking a MATLAB course that deals... Ooh! I did a MATLAB numerical methods course. It's fun. Oh, dwarf kek. Can you make a graph of x squared plus y squared minus... The notations... Yeah, we can make a graph out of that. I'm assuming those are exponents up there. Midpoint method / Newton's method / regular falsy. I'd never heard of the regular falsy. Oh, guess and check? Oh, okay. Huh. Interesting. Yeah, I mean, I assume if you're just using like a built-in, I don't actually know this, but it's my assumption that if you're using like some kind of like, you know, NumPy's library or Mathematica or whatever, they calculate sines using a power series. That's what I assume at least. So even if like, for the sake of MATLAB, you're saying sine of this thing, I assume in the back they're doing a power series anyway. They're not? I don't really understand the syntax then, Dwarfkek. Like, are those subscripts then? Or like, what are those, like, what is x2, y2? Oh, I've seen that one before then. Yeah, those should be powers. Let me, see if I can make it work. Yeah. It's a heart. Where can I ask more questions? Thank you, Dwarfkek. I mostly answer them just during the stream here, but I do have a Discord where you can put questions. Yeah, it's really just like asking me in the chat and in the Discord. Oh, yeah, that Matlock probably does a built-in root finding function. Oh, wait, is Penn Center live? I didn't even see the time. He is live. Okay. I think we're gonna wrap the stream here then. I have to check at the right time then, I guess. Okay, so yeah, I'm gonna cut the YouTube stream off here and raid out the Penn Center. Should have come to the E class. I was able to watch a little bit of it, OB, but at least the Wednesday one is right when I normally start my stream, so I normally catch the Monday ones live. Okay, so yeah, I'm gonna cut the YouTube stream off here, so YouTube people, I appreciate you. I'll be back on YouTube on Saturday.